we're supposed to write an equation that relates the rate of change of the area with respect to time to the rate of change of the length with respect to time and the rate of change of the width with respect to time. Okay, so it's just going to be an equation. So what they're saying is that there's some sort of rectangle, and the rectangle is changing. The dimensions are changing. Maybe the length is growing at like 2 feet per second, and the wait, that would be the width. The width is growing 2 feet per second. The length is growing 3 feet per second, something like that. It actually have to be proportional because it's a rectangle. So I just made up some numbers that probably don't perfectly fit. But the idea is that this triangle is growing or shrinking, one of the two. The area is changing. So to figure out what the area is with respect to this variable time, we need implicit differentiation. We're going to take a derivative of the entire area equation with respect to time, because we want to find out how fast the width is changing with respect to time, how fast the length is changing with respect to time. Now if you do that, since it's a derivative, then it kind of acts like the distributive property because it's a linear operator. That's dA dt. We don't know what the derivative of the area is with respect to time explicitly, so we're going to write it like this, implicit differentiation. And same thing over here. The length, we don't know what it is with respect to time in an explicit formula. We don't know that the length is 2t squared minus 4t to the third or something like that. So all we can do is we can say that this is some sort of function with respect to t. This is some sort of function with respect to t. So if we're going to try to differentiate this side, we need to use the product rule. It's a derivative of the first function. I'm going to use capital L. With the second function kept the same. Plus a derivative of the second function with the first function kept the same. We could have write it. I usually would write the first function here, but it doesn't matter. I think that's basically it. Now they just want us to plug in the length is 18 and the width is 13. So if you plug that into this equation, the rate of change of the area with respect to time, W is 13, so it's 13 as a coefficient here, 13 dL dt. And then it's 18 dW dt. Okay, so the area is changing with respect to time. And what the area is after a certain amount of time is equal to 13 times the rate of change of the length with respect to time, plus 18 times the rate of change of the width with respect to time.